In addition to the functions we learned in the previous tutorial, let's learn a few more functions which are not majorly used in our day-to-day work but can be useful when you carry out specific calculations. Let's see the first function, which is the radian function. This function is used to convert angles from radians to degrees. Let's enter the formula for radians in the answer cell. Start with an equal sign and type radians. When the radians appears in the autocomplete list, press Tab to select the function. Now we have to enter the angle in degrees. You can type the angle value here. Say 180. Close parenthesis. Excel returns us the angle in radians. But it is always a better idea to use cell references, as this will allow you to change the input without editing the formula. So let's give it a cell reference C4. Now when you change the values in C4, the answer is updated automatically. Next function is the degree function. Degree function converts the angles from radians to degrees. Click on cell E6 and you can see in the formula bar that the formula has already been entered. This is the reason why this cell is showing the value 0. For your reference, we have written the formula used in cell C6 in the formula column. Let's enter an angle in radians which you want to convert into degrees. Say 1 radian. The answer in degrees is displayed in cell E6. Let's see some trigonometric functions like sine, cos and tan. Select cell E11 and start the function with an equal sign. Start typing sine and press the Tab key to select it. The sine function in Excel always takes the input in radians, but the input that we are going to give is in degrees. So it is necessary to convert the angle into radians first. To do that, let's enter the radian function inside sine function. Start typing the radian function immediately after the open parenthesis. When it appears in the autocomplete list, press the Tab key to select it. Now let's select cell C11. Every left parenthesis must have a matching right parenthesis. If you have many levels of parentheses, keeping them straight can sometimes be difficult. If the parenthesis doesn't match, Excel displays a message explaining the problem and won't let you enter the formula. Clicking on Yes, Excel will automatically correct the formula and give us the answer. In this sheet, I have entered the formulas for cos as well as tan function. You can see the syntax of this formula in the formula column. Let's give input values for cos and tan and we get the answers in the answer column. Now let's learn a few basic arithmetic functions. First is the square root function, which calculates the square root of a given number. Let's enter a value here, say 25. And we get the answer 5 in the answer cell. Next is the least common multiple function, that is the LCM function. I have already entered the formula for LCM. It is showing us an error here as the input values are not entered. Let's enter two values in these two cells, say 3 and 6. The LCM of the two numbers is displayed in the answer column. The GCD or the HCF functions works in a similar manner. The power function calculates the value of a number raised to another number. Let's type the formula. First, Excel asks us to enter the number. Let's select cell C23, put in a comma, and then enter cell C24 for power. Close parenthesis. In the number input, let's type in 5 and for power, let's type in 2. We get the answer 25 as 5 raised to 2 is 25. In the product function, we get the product of two numbers. We also have a few functions related to exponentials and logarithms. The exponential function returns the value of e raised to any number. The syntax is written in the formula column. Let's input a value, say 0. As e raised to 0 is 1, we get the answer 1. The ln function returns a natural logarithm of a number. Enter a value, say 1. Natural log of 1 is 0, hence we get the answer. The last function we have here is to calculate the value of log to the base 10 of a number. Let's enter the value 10 and we get the answer 1. This concludes our tutorial on general math functions.